All right, let's work through some example problems for both work and power. Here it says Susan used 7.5 newtons of force to lift an object 18.4 meters. How much work did Susan do? So we're going to identify our variables. We have a force of 7.5 newtons. We have a displacement of 18.4 meters. And I personally think it will be helpful if we draw a picture or at least draw some vectors or maybe use X and Y subscripts to make sure that we are paying attention to what axis these different variables are on. Because if you recall, that's important in determining how much work was done and what numbers actually need to go in our question. So it says here that Susan performed 7.5 newtons of force to lift an object. So this force is going to be an upward force. And if she's lifting an object 18.4 meters, it is implied that this is the vertical displacement that Susan moved the object. So that is also going to be vertical. How much work did Susan do? So work is what we are looking for. So this question is very simple and straightforward. Work is equal to force times displacement. So we are going to say 7.5 times 18.4. And we get 138. And so we are going to round that for sig figs. 2 sig figs is the least number we were given. So 140 joules. Okay, next question. You did 170 joules of work lifting a 140 Newton backpack. How high did you lift the backpack? So now we are going to start with the amount of work that was performed. So they tell us that we have work of 170 joules. And once again, this work was being done so that we could lift an object. So this is a vertical work or work on the y-axis. We are lifting a 140 Newton backpack. So that is actually the weight of my backpack. Now, if you recall from our lesson, we said that we are going to assume that all lifted objects are going to be lifted at a constant speed. And if that is the case, then that means that the vertical forces need to be equal magnitudes in order for the object to have a constant velocity as it is lifted. This would be my force due to gravity or the weight. This would be my applied force. So in this question, when they tell me that I have a 140 Newton backpack, they're also telling me that I have an applied force of 140 newtons, and that force is also going to be an upward or vertical force. Okay, so both this work and this force go together. Awesome. They are asking me what is the displacement of the backpack. And again, because the backpack is being lifted, this would be a vertical displacement. So I don't have to do anything special or tricky here. I'm just going to take this information. I'm going to plug it into my equation. Work is equal to force times displacement. And then I'm going to substitute in 170 is equal to 140 times D. So I'm going to divide both sides by 140. Make sure you do the same thing on both sides. So I'm going to get 1.21428, blah, blah, blah. And so we are going to round that for sig figs. So we have 2 sig figs once again, both 170 and 140 only have 2 sig figs in this problem. So we have a vertical displacement of 1.2 meters. All right, next question. If Sam performs 4,000 joules of work while dragging a tarp 10 meters, so my displacement is 10 meters, how much force did he use? So they are asking us how much force was needed to perform this work. So work is equal to force times displacement, this should be 4,000 is equal to force times 10. So we'll divide both sides by 10. And there is my force. All right, now let's look at some power questions. What is the power of a man that lifts a 356 joules in 42 seconds? All right, so we're going to list our givens. We have joules, which is going to represent how much work was performed when this person lifted the object. And we have a time of 42 seconds. So here they're asking us how much power. So remember, our equation is power is work divided by time. So we're going to say power is 356 divided by 42. And that's going to give us 8.4761, blah, blah, blah. And so let's round that for sig figs. This time, both of my values have 3 significant figures. So we are going to say 8.48. And remember, our unit for power is watts. Okay, next question. You can lift your own weight. So you have a weight of 500 newtons, and you lift your own weight up a staircase that is 5 meters high in 30 seconds. How much power do you use? All right, so we have a weight of 500 newtons, but we're going to use this to lift ourselves. So our applied force on that vertical axis is going to be 500 newtons. We're going to go up a staircase. So here's my staircase, and that staircase is going to be 5 meters tall. Ooh, let's try that again. 5 meters tall. So I'm not saying this is 5 meters. That is incorrect. I am saying this right here is 5 meters. So this is going to be a vertical displacement of 5 meters when I go up this staircase. It says that it takes me 30 seconds to do that. So what is my power? I am looking for power. So remember, power is equal to work divided by time. But in this case, I don't know how much work I did. I know that I lifted myself up the stairwell, but I don't know how much work that was. So we're going to have to go and figure out how much work did I perform to lift my body weight 5 meters up the stairs. So I am going to need to take my body weight of 500, multiply that by 5 to figure out how much work I performed. Oops, one too many zeros. How much work I performed. And now that I know how much work I did, I'm going to take that and I'm going to plug it in over here to my power equation. So I am now going to say power is equal to work divided by time. So I'm going to take 2,500 divided by the 30. Remember, use that answer button if we're continuing this problem in our calculator. And so this is going to give me 83.3 repeating. And so I'm going to round that for sig figs. In this question, 5 meters was our limiting factor because it was only 1 sig fig. So remember, the Espinosa rule says we're going to round that to 2 sig figs instead of just the 1 digit. So we're going to make this 83 watts. Now, if you're working a problem like this in the future, do you have to make it a 2-step problem? Well, remember, we've talked about how we want to make sure that we are being as efficient as possible with our math. And if you have the understanding and ability to, instead of making this a 2-step problem, if you would just want to merge this into one, that would be completely fine. What I did was I took my force times distance use that as my work. And since that is here in my equation, what I want you to recognize is right now everything in yellow, they're all interchangeable. They are synonymous. So I could absolutely recognize that power is going to be work divided by time. And since I don't know my work, I could just simply come here and I could replace work with force times distance, because that's what it is equivalent to. Now, you won't have this on the board, on the formula list. However, this would be 100% acceptable and appropriate for writing our equation for a question like this. There are going to be some two-step situations that you're going to need to do quite often. And so if you get more comfortable and you understand, oh, it's just going to turn into this, I would love to see you go ahead and write it out as power is force times distance over time. If you're not ready for that, if that's not how your brain works, if you have to say, no, I've got to go find my work, and now work goes in the power equation, then by all means do that. Either method, if performed correctly, will give you the right answer every time. Okay? All right. I believe we have one last question here. Yes. How does this compare to a 100-watt light bulb? So this is a pretty specific question, but I'm asking this question because you might see something like this in the future. Here's what I need you to understand. If you have a power rating of 83 watts and the light bulb has a power rating of 100 watts, then in general, I need you to know that the light bulb is more powerful than you. That's what I need you to know. So the light bulb is more powerful. That is the answer. Okay?